My name is Alhusam Al Harthy, and we are Group 10, Power 10, and we built a controllable power supply. I worked in the LCD touchscreen and LCD display and user interface.
Hi, my name is Tianbao Yan. I worked on AC to DC converter and PCB design.
Hi, my name is Ian Brysen Pagatpatan. I worked on the Arduino communication and sensor implementation.
For this project, it is an adjustable power supply that supplies voltage from 2 to 14 volts under a load of up to 1.5 amps, while displaying the voltage and current to an LCD display. The power supply is able to be modified using the buttons on the power supply and through a computer using a serial connection.
As we built this project, it included several requirements to be implemented into the power supply, which are the following. We are required to have at least 2 separate channels with a minimum range of 2 to 14 volts. Also, we implemented the ability for the power supply to supply 1.5 amps to each channel. In terms of safety, we were required to use US standard plugins for external connections. We also had to build an enclosure that doesn't allow objects to enter with a 1 millimeter diameter. And we also had to ensure that the power supply is disabled when 1 amp is drawn from the wall and or 1.5 amps from any channel output. Moving on, the system must have been able to output accurate current and voltage values within 5% or 0.1 volts of actual values. Also, we had to implement a programmable feature where the user is able to change the output voltage and current values using SCPI protocol. Lastly, in terms of our additional requirements, we decided to implement a USB charging point for a 3rd channel and implement a touchscreen for our user interface. You'll see all of this be demonstrated later in the video.
Now we move on to our block diagram. This allows us to visualize the overall main parts of the project. Once we did that, we selected the project into 3 parts to assign it to each member. As you can see in this block diagram, Tianbao's block is labeled in green, which includes the AC to DC power conversion and transformer rectifier voltage regulator. For Alhusam's part, in red, involved the user interface with LCD touchscreen and display, as well as the enclosure design. Lastly, for Ian Bart, labeled in blue, he worked with Arduino communication and sensor implementation. All together, it's make up the PC-controlled power supply. So as I said before, I worked in the designing the enclosure and the touch screen and LCD display. So as shown here, the design for the enclosure, which is 12 by 6 by 6, and here's the design for the front face of the project. And as shown here, the final product, which is what we got after we used laser cut to get the final enclosure. And also here the LCD display, which is 20 by 4, and the LCD touchscreen, which is 2.4 inches. Also, I worked in the user interface. As shown here, it can be controlled manually, which is by choosing a number, or by or by the touchscreen, and over the SCPI protocol. So when each section has different menu for it, which we have 4 menus. And also I work in designing the touchscreen, which is showing here the design for the touchscreen and the design for how they display the channel 1 and 2.
AC to DC converter and PCB design. First, we have a 24 volts transformer, which can step down the work power from 120 volts to 24 volts. Then we have a rectifier right here, which will rectify the AC power to DC power. And then we have 3 channels. Channel 1 and channel 2 are adjustable, and the 3rd one is not. We use 2 DC paths right here. So we change the DC path value to change the output voltage. For the 3rd channel, we just used a fixed value resistor, so we can output a 5 volts constant voltage.
Alright, so I worked with the Arduino communication and sensor implementation, and you can see here I have the schematics for the sensors. So To measure the voltage of each channel output, I set up a simple voltage divider here with a 2.2K resistor and a 1K resistor. And for the current sensor, we use an ECE342, and I had that set up directly with the load in series, and that was able to measure the current. So in our power supply, we have the sensor portion of the project implemented right here. You can see the two resistors to make up the voltage divider, and you can see the current sensors here to measure the current.
Okay, I'm gonna start the demonstration for the project, and we're gonna test one channel of the two because both of them doing the same thing. Okay, we go to channel 1, then enable channel 1, which is enabled and already set to 3 volts, and we can disable it, which is gonna be 0, and we re-enable it and set the voltage to, for example, 7 volt. It's gonna display here in the multimeter 7 volt, which is and also here it's on and 7 volt. So now I'm gonna test the SCPI commands for channel 1, which is basically we can control channel 1 and channel 2 through it. Volt 1, we can set it, for example, to 4 volts, and it's showing here the 4 volts also in the LCD. Now I'm going to test the touch screen, and here through the touch screen we can enable and disable the channels, both of them, 1 and 2 and 3. When 3 enable, it's fixed 5 volts, and as it's showing, we can control channel 3 through the touch screen and from the serial monitor. So I'm gonna enable channel 1, and increase the voltage, which is, it was initially 7 and now it's increased to 8, now 9, and we can go up to 14 volts, and we can't go any higher than 14 volts.
Reflecting back on the project, we faced a lot of challenges as we built the PC-controlled power supply. These included initial design of a power supply as it was unfamiliar to our knowledge. It took us a while to integrate our blocks fully functioning as one, and managing our time over the course of the term was a big challenge as well. In terms of future improvements, we would like to implement wireless capabilities, create a more compact power supply using smaller yet powerful components, reorganize and decrease our wiring, and also create a wider range of current and voltage output. Looking back at the project, it was a great way to get our hands on an actual project. Also, it was a good way to apply the concepts we learned in ECE, and also grow as individuals in a collaborative setting.
And thank you for watching, and we hope you enjoy the video.